Graphing a function given another function with translations and transformations can be done in a couple of different ways. I want to demonstrate perhaps a way you haven't seen, but a way that's very secure. So first off, our first graph is piecewise linear. So we have a couple of points. This first point is -4, 2. And then we have the end point of that first segment and the starting point of the second as 1, -2, and our last point being 2, 3. Now what this actually means is f of -4 equals 2, f of 1 equals -2, and f of 2 equals 3. Three facts we know about the function f. So for this other function, if I were to plot points, and I want to have -4, so if I plug in 0 for x, I get negative f of 0 minus 4, -4 minus 3. I know what f of -4 is. It's 2. This is -2 minus 3, -5. So we have 0, -5. Let's put that down. 0, -5. Next point, I want it to have a 1 in there. So if I plug in 5 for x, I'll have negative f of 1 minus 3, which we know that is negative f of 1 is -2. That's 2 minus 3, -1. So we have 5, -1. And the third point, I want 2. So if I plug in 6 for x, I will get negative f of 2 minus 3. And we know f of 2. It's 3. So minus 3 minus 3, that's minus 6. So 6, -6. These are the endpoints of the line segments. If we connect them, we will have the graph of the translated transformed function g of x. Hopefully this gives you an idea of why the other patterns work. Specifically, if we wanted another way to think through this, starting from the x, the first thing that the x sees is the -4. So that means it shifts it left 4. So 1, 2, 3, 4, everything going left 4. Why do I have left 4? I am so sorry. This is right 4 because the -4, opposite, right 4. Everything moves to the right, 4. So that would be this shape. Next up from the x would be the negative. Changing the y value is an x reflection. So then this stuff gets x reflected. This point goes up to here. This point goes down to here. This point goes down to there. And finally, down 3. Everything down 3, we can see 1, 2, 3. That's a final point, this down 3. Final point, this down 3. Final point. Oh, wait. What happened? Oh, no, this point down 3. There we go. And that's our final shape. So you have to go from inside out and see the changes as we move from the x. What's the first thing it sees? The -4. Move right 4. Then the x reflection, then the down 3. So you can follow that to get the final answer as well. But I wanted to show you a different approach that again is very secure because it uses the facts that are given to directly find new points.